So in the last threads videos, we have discussed several methods of threads and several ways of implementing threads, extending from thread, implementing from runnable, implementing using anonymous class. We implemented threads, and then we then later covered how to control the thread execution by using thread synchronization, using wait and notify methods. That example we have seen. Both method level synchronization as well as object level synchronization you have seen. And with the anonymous class also we implemented object synchronization. 3 examples on synchronization we covered. Then we saw the example on how to name and retrieve the threads. That is very important. Thread.current thread method is very important. And how to set and influence the priority on the threads also. We have covered in the last session. And today is the last topic on threads. As I promised you that I'll cover all the thread functions and the thread lifecycle in the last topic. This is the topic. So here I am going to cover both the thread lifecycle and as well as the list of methods exist in the thread class, their brief description. Then followed by I will cover the brief introduction about sleep method. These methods are used to control the thread flow of execution. Sleep method, yield method, and join method. With that, we will end up this topic. So before coming to the thread lifecycle, I just want to give a brief glance on the thread API, thread class, and then I'll go to thread lifecycle functions. From that lifecycle functions, I'll come to explain where all these methods are used. If you come to the thread class is in java.lang package. Point number 1. Thread class exists in java.lang package. That we already know. This class extended from java.lang.object, the supermost class, to all the Java classes in Java API. And the class is also implemented from a runnable interface. Thread class extends object, implements runnable interface, and it got some variables and methods in this class that we will discuss in brief. So that is how the class is declared. This public class thread extends object, implements runnable. The next coming to, if you observe any Java class API in the API documentation, there also after the class declaration, they'll explain the variables description, then the list of constructors, or they call it as variable summary, constructor summary, and method summary. The same way we are covering in thread class, 3 constant variables are given called min underscore priority, norm underscore priority, and max underscore priority. Internally, their values are 1, 5, and 10 respectively. So as a developer, we need not have to worry about what is the integer value of minimum priority, normal priority, or maximum priority. We can directly use these priority variables in thread class set priority method to increase or reduce the priority of the thread's execution. And all these 3 variables are public static final int variables. As you already know, the final variables are declared in capital letter, and most of the final variables are static too. I forgot to write final here. Public static final int. Final common to all. Public static final int. Public static final int. Min underscore priority, norm underscore priority, max underscore priority. The next in the thread class, mainly three constructors exist. One no argument constructor, one string argument constructor, and one runnable argument constructor. I would like to give a brief explanation on where this thread class no argument constructor, where this thread with string name argument constructor, and where this runnable argument constructor are useful in the thread programming, because we cannot come to discuss about the constructors once we enter into the methods, life cycle functions, and other stuff. So I want to give you a brief introduction on when this thread class no argument constructor is useful. Suppose if you write a public class called myThread, because as you already know the basics of constructor, which I have explained in the object-oriented programming. If you write public class myThread extends thread, and if you write a normal thread class, and mostly what we'll do is in the thread subclass, we'll implement run method mostly, and we'll try to concentrate on writing the logic here, but which is not recommended, or from here we'll call different methods on class whose methods want to run concurrently. Okay, so the run method will concentrate on that. But if you don't write any constructor in the thread class, if you don't write any constructor in thread class, if you don't write any constructor in any Java class, by default Java compiler will generate one no parameter constructor. One no parameter constructor it will generate whose access specifier is same as class access specifier, and if class is public, public no parameter constructor will be generated. If class is default, with a default access specifier, one no parameter constructor will be generated. So anyway, if you don't write any constructor, by default one constructor will be generated, name called public myThread with no parameter. And tell me, what is the first statement in every class constructor before doing some initializations? In every class constructor, the default statement is superof. That means calling superclass constructor. What is the superclass of myThread? Thread class. And from here, this constructor is called. And if we assume that we are not using that thread, no. If you write a thread class extending from thread, and if you don't write any constructor, or even if you write a blank constructor, the first statement in every constructor is calling superclass no parameter constructor finish. So your constructor is generated by default. The superclass constructor is also called by default. Then only object is created, and further this through start method, this run method will run. Okay. Then you may ask me, what is the use of this calling superclass constructor, and what is the use of this thread no parameter constructor? This constructor, and this is the internal process of thread class. They don't show us in the thread class. They don't show us, but internally they'll declare one variable called string name. Probably this variable may be a private variable. If it is private variable, it should be given in the documentation, but they completely hide this variable name, string name of the thread. In this no parameter constructor, what they'll do is, if you don't assign any name, because you are not assigning any name, internally they'll assign this dot name is equal to as many number of thread objects you create in the client program. To each thread object, and in thread scheduler, as many new objects you create. For each object, it is going to increment some integer value. And for the first thread -0 will be assigned as a thread name. For the second thread -1, thread -2, thread -3, and so on. And the purpose of this no parameter constructor in thread class is assigning a default name to every thread. If you don't assign any name, by default they'll assign thread -0, 1, 2, 3, 4, 5, 6, so on and so on. Fine. And what about this second constructor? What about the second constructor? I'm explaining about thread class constructor and the next, all the thread functions. After showing almost more than 1, 2, 3, 4, 5, 6, 7, 8 programs. After 8 programs, I'm explaining the constructors, variables, and methods of thread class, then followed by thread lifecycle. Now, I'll get a full chance to explain all these methods. Okay. And suppose if you write a my thread class extending from thread, and you want to see, and I want to assign, I don't want to assign the name something like thread-0, thread-1, thread-2, like that, a default value. I want to give some name, like some file download thread, or payment processing thread, or tax calculation thread, or calculate salary thread, or calculating average marks, or progress card, and preparing progress card of the student. For that one method, we are writing one thread. So the thread name may be progress card preparation thread, something like that. Because in a semester, in an engineering college, if having some 7-8 branches, around roughly 800,000 students exist. In 1 year, 1 semester, or in 1 year, those many number of student progress cards want to be generated by taking their marks list. So you certainly need a constructor, you certainly need a thread which process and generates progress cards for all the 1,000 students. And if any student's progress card generation gets delayed, the time should not influence, or that time should not impact on other student progress card generations. So generally when a method wants to run multiple times, or when multiple methods want to run, when a method want to run multiple times, or when multiple methods want to run simultaneously, then we will go for threads, right? So thread per method basis, remember. So somehow I'm writing my class name called public class method extends thread. It has some significance. So I'll explicitly write public my thread. Then what I'll do? I'll ask my clients who are creating my object, my thread class object. To them, I'll ask them, please provide me whatever name you give. I'll assign that name to the thread. So you to take string name, and you pass that sopraf, that name, into second constructor of thread class. So internally that name will be assigned. So from where this name is assigned in the client program, whoever creating my thread mt1 is equal to new my thread of student number, some 1297 something, some number exists, that roll number, that student progress card. And then probably we'll generate this name also through some loop and with an array of all the student roll numbers. So each student roll number will pass, will concatenate progress card, followed by that roll number. That is how we'll generate one thread name, and that thread name we want to assign to MT1. So while running the application in the run method, while writing the debug statements, we started progress card preparation for so-and-so student, and total marks calculated for the so-and-so roll number student. Like that, every time the debug statement will print with this thread name, so that we'll come to know, okay, this student progress card processing is progress up to what extent we can monitor on the log files. So that is the purpose of second constructor. Okay, here we'll take from the client, we are creating my thread class object. Through them, we'll take the name of the thread. Doesn't mean that, everyone will assign my thread one. With roll number, some progress card in concatenation with the name that will pass here. So each thread will be assigned with roll number followed by progress card. Okay. And what about the third constructor? What about the third constructor? Yesterday we saw two types of threads creation. Two types of threads creation. One is, public class my thread extends thread. This is one way of writing the thread, isn't it? Here also we need to implement public void, we need to override public void run method. The other way is public class my runnable implements runnable. Here also we'll write public void run. We say here we are implementing run method coming from runnable interface. Here we are overriding run method coming from thread class, because from the class always implemented methods will come. When we rewrite, we'll call them as overriding. So whatever it is, rewriting or overriding or implementing, we are implementing run method. That's it. Okay. But how this thread object is created and started, and how this thread object is created and started. In the client program, if you want to create object of the my thread, we write empty1 is equal to new my thread of. Because my thread is a subclass of thread class, from thread class all these methods will come. Start method will come, run method will come, destroy, interrupt, is alive, is demon, set demon, current thread, and so many other methods. Set name, get name, set priority, get priority, sleep, suspend, resume, join, wait, join, yield. All these methods will come from the thread class. So directly we'll call empty1 start. Empty1 start. So as you already know, on as many number of thread objects you call start method, there is a thread scheduler in which all the threads will be registered. And from here, each thread class run method will be called from the thread scheduler. It is the job of the thread scheduler. It will take care of how concurrently the control want to give to each thread to run. It all, thread scheduler will take care. Just as a developer or programmer, our job is only to start the thread. What about class implemented from runnable interface? How do you create object of that? So my runnable mr is equal to new my runnable of. Runnable interface is having which method? Runnable interface is having only one public abstract word run method. Only one method, public abstract word run. That we are implementing here, of course. Thread class also is a subclass of runnable interface. That method we are implementing here. Can you call my runnable dot start? It's having only run method but not start. Then how do you run the run method of that runnable subclass? Because since there is no start method, so what we need to pass is, what we need to do is, soon after creation of my runnable object, we need to create one thread object. Thread t1 is equal to new thread of. Into thread class constructor, we need to pass a runnable object as argument. Now this my runnable object is assigned to thread. Now we write t1 dot start. Finish. So this thread will run. If you extend from thread class, you directly call start method on thread object. If you implement from runnable interface, you create object of runnable interface, pass that into thread class constructor, create thread object, and call thread dot start. So hope you understood how all the three thread class constructors are used. Because of here thread class constructor is taking runnable object, we are passing mr here. Mr is a subclass of runnable interface. So I hope the constructor concept is clear to all of you. Next, I am moving to explain briefly about all the methods of the thread class, and then I'll go to, because already we saw some methods and some methods are left over. Those methods I'll cover at the end. Coming to the thread class, in thread class, the three main lifecycle methods are start, not three, of course, one, start, run, stop. Destroy method is deprecated. In the place of destroy method, interrupt method is given. Thread dot start, thread dot destroy, thread dot run. Thread dot destroy is deprecated method. So if you use thread object dot destroy method anywhere, we'll get a compilation warning, not runtime error, compilation warning saying that the desktop method of the thread class is deprecated. Please use alternative method. Please refer API documentation for the alternative method. If you go and read the API documentation, the alternative method for the desktop is given as interrupt. So you can use interrupt method. Start, run, and destroy or interrupt, whatever it is. This is deprecated due to some concurrent issues and deadlock issues. That's a different concept. So these three are the main lifecycle functions. Start, run, and interrupt are the three lifecycle functions. To start the thread, the start method registers the thread object into thread scheduler. Thread scheduler will call the run method. Like that, thread scheduler will call run method on all the threads and makes all the run methods run simultaneously. That thread scheduler will take care. And third one is a desktop method. Desktop method, though you don't use once thread execution is completed, thread object will be destroyed, and in rare cases will stop the thread or will interrupt the thread. So these three methods are completed. 3 or 4 methods, whatever. And on any thread object, if you call is alive, the method will return boolean value whether thread object is alive or not. Whether thread object ended up or thread object is it running. Okay, but don't forget about daemon threads. This thread dot current thread, this static method I have already explained. So why? Because there is a class with M1 and M2. And yesterday we generated number generator class, generate and print method, 2 methods. For 2 methods, we wrote 2 thread classes. Do you remember? So otherwise you write M1 thread extends thread class M2 thread. Therefore generate thread and print thread yesterday we have written. So here I am taking M1 method and M2 method. So for that the thread names are M1 thread and M2 thread extends thread. And then in the client program, we'll create object of M1 thread, M1t is equal to new M1 thread of. Similarly, M2 thread is equal to new M2 thread of. Then there is a concept called a set name. You can either pass through constructor and pass that to superclass constructor to assign the name, or you can directly use one method called M1 thread dot set name of. You can give some name. Similarly, M2 thread dot set name. You can give some name here. Finally, you call M1 thread dot start and M2 thread inside. See, remember, methods are M1 and M2. They want to run concurrently. M1 and M2 are the methods, they want to run concurrently. But to concurrently run the methods, by default, in every programming language, the methods execution model is sequential model. Okay. So methods always executes in sequential model. If they want to run concurrently or simultaneously, then the only option is for each method you write one thread. From the thread class run method, you call the methods. From the run method of thread class, you call these 2 methods. That is the process. And to these threads in the client program, we are creating objects, we are setting the name, and we are starting the thread. So we may start the thread in the client program, or we may, we may assign name to the threads in the client program, or we may assign the name to threads in the each class constructor, because by calling the superclass constructor. The thread names are usually assigned by the client or through a client. The thread class will assign the name to the thread. But the methods which are running, the so-called M1 and M2, the methods which are running in the threads, these methods don't know in which threads they are running. Yesterday I told this point, regarding the thread.current thread explanation. M1 thread knows that I am calling M1 and M2 thread knows that I am calling M2. Threads knows which methods they are calling. But these two methods don't know in which threads they are running. They don't know that they're being run by threads. They may guess like they'll be called normally as equation methods. But these methods don't know in which threads they are running, but the methods want to get in whichever thread they are running that thread name they want to retrieve for the debugging sake, because each method is having some 100 to 1000 lines of code. So in the entire 100, if you write at least 100 lines of code, in the 100 lines of code, at least we'll write 10% of the at least 10 lines of debug statements. We'll write. For every 4-5 lines or 10 lines, we'll write one debug statement. It not only happens in the Java. In every programming language, everywhere, debugging is the only option for the developer to find out where the error is, and to see the progress of the program execution. The only way is writing debug statements. In the 100 lines, if you write 10 debug statements, later on you may remove it or you may ignore it or you do something. Okay. But without writing debug statements, no developer will usually write the code. So by debugging, what method do you use to write the debug statement? Usually you will print the method name, or you will print the class name, or you will print the thread name, right? So these methods want to get which name is assigned by the client. That name they want to get, and they want to write the print statement. So how do they get the thread name? How these methods know in which thread they are running? That is why in thread class, directly one method is given called thread class dot current thread is a static method. You are calling with class name, not the object. Thread dot current thread, that will return in which thread this method is running. Dot get name, so the name will come. That name they use for writing the debug statements. And the methods will get the thread name to write the debug statements by via calling thread dot current thread. Hope this is clear. And the next coming, these are the methods of the thread class. Beside this, I have given how the runnable interface method is given, public abstract method. And the two commonly used properties, if required, are set name, get name, set priority, get priority. If you are interested, you can change the priority of the threads by passing 1 to 10 numbers, or thread dot min underscore priority, or thread dot norm underscore priority, or thread dot max underscore priority, or thread dot min underscore plus thread dot min underscore priority plus 2. The thread dot min underscore priority plus 2 and the thread dot min underscore priority is 1 plus 2 means 3. Thread dot max underscore priority minus 2 and the thread dot max underscore priority is 10 minus 2 is 8. So you can, like that, you can vary the priority of the threads from 1 to 10 in between. If you give any value below 1 or above 10, will cause an illegal argument exception that yesterday I have explained. So you can change the priority of the thread, you can assign name to the thread. These methods are known. Sleep method also yesterday we used. In the next slide, we are having explanation on sleep method. Where sleep method must be returned is also given here. The example is clearly. Most of the times, the developers will, and if anybody teaches about sleep method, they'll call sleep method in the main method. So main is the method from which the client program execution starts, but the actual code lies in the thread class run method or in the methods which are called from the thread. There the actual logic lies. But if you want to write sleep method, if you want to call the sleep method, you must call the sleep method in generate and print methods or in generate thread and print thread classes, but not in the client, right? So uses of thread.sleep method I found in many examples in the wrong situations. So because we want to instruct a thread to sleep, or we want to instruct a method in which it is running the thread, through the method we want request. That is why the sleep method is a static method. The reason I'll tell you. In the next slide I'll explain you. Sleep method is a static method. You will call that method you'll call that thread.sleep method in the method where you are writing the logic. The method which next runs in the thread with other threads. So that is why The logic which are implementing the generate and print method, they are not belongs to thread. But how can you call thread class sleep method in non-thread classes? Just like current thread. Next slide we'll see that. Anyway, sleep method we'll see. It is overloaded for twice. So sleep method with long milliseconds and long milliseconds comma in nanoseconds. Mostly we use long milliseconds. 1000 milliseconds is equal to 1 second. Like that you calculate and do. Suspend and resume, these two methods are deprecated. So we are not using it. We are not doing any examples. And the example of suspend and resume, these two methods are exactly identical to we used wait and notify methods we used in method synchronization program and object synchronization program. Please go and see there. We used wait method and we used notify method in generate and produce methods, both in synchronized method and as well as in non-synchronized method where the object synchronization process also. We use the wait and notify methods in generate and consumer something. Generate and print, I believe. Generate and print methods. In those methods, we use wait and notify methods. So to stop the thread execution, to notify which threads are waiting for the execution, notifying the other threads to execute. So we used wait and notify in those examples. Method synchronization, object synchronization, and through anonymous class, we implemented object synchronization. 3 examples on synchronization I have given in the last videos. So the suspend and resume methods are exactly equal to those wait and notify methods. Preferred means of synchronizing threads is through a wait and notify, but not through a suspend and resume. Stop using these two methods. These two are deprecated. Deprecated methods are marked recommended not to use, but they are not removed for the future compatibility. Suppose suddenly if they are removed. If in the new version of JDK, if old version of the project runs, if these two methods are not present, immediately, one day I have explained the exception topic, I guess. I have explained about no such method error. I have explained, so that error will come. Suppose if any such deprecated methods are removed in the JDK and old application runs on the new version of JDK, no such method error problems will come. So that's why generally Sun Microsystems, the previous vendor of Java, they have not removed any deprecated methods from the classes, but they just marked the methods as deprecated. Methods which developers should not use, they mark those methods as deprecated. So these were deprecated. Deprecated for different reasons. And then next coming to what is the alternative of suspend, wait, and what is the alternative of resume, notify. Here the trickiest part of the wait and notify methods are wait and notify methods are given in Java.lang.object class, but not in thread. In thread, all the methods are given in thread class, but wait with the different overload signature, wait with long millisecond, come nanosecond, notify. Wait and notify methods are given in the non-thread classes in Java.lang.object. In Java.lang.object means this wait and notify methods are available to all the Java classes in Java API. Wait and notify methods are available in all the classes of Java API, but these methods are not part of thread class. You know why? The reason is, you tell me, through a thread API we control the thread's execution, like by calling start method and by calling run method, by calling interrupt method, set priority, get priority, set name, get name, various join, yield, etc. methods. But tell me where the logic is implemented and from where that logic implemented methods are called from. Logic is implemented in the non-thread classes like number generator class. Generate and print are the two methods. It is a non-thread class. But whose methods but those methods under that number generator class methods want to be used in multiple threads to make these methods run simultaneously, because methods cannot run simultaneously. So each method assigned to one thread and threads will run simultaneously. That's how methods get executed simultaneously indirectly. So the logic is implemented in the non-thread classes but not in the thread classes. In the thread class run method, the strict recommendation is to call whichever methods you want to run concurrently. You just call them for 1 time or 100 times or 1000 times, but don't try to implement the logic in run method. Implementing logic in run method is not recommended, because we shouldn't call that as a logic. We shouldn't call that as a business logic. We shouldn't call that as a end user logic. What is the name of the method name? Run. How do you write some calculation, some logic in the run method? The logic and method doesn't match. So in thread class run method, the recommendation is only to call whichever methods you want to run concurrently, just call them. So where the logic is implemented in the non-thread classes, like number generator class, generate and print method. So where this wait and notify methods want to be used, wait and notify methods want to be used in non-thread classes, but not in thread classes. Are you getting me? Please go and check the synchronized method example. That is why wait and notify methods are given available common to all the java.lang.object classes, means to all the classes in Java API, but they were not kept in the thread API. They should be part of wait and notify, should be part of each and every class in Java, but they shouldn't be part of the thread class. So that point is clear. Same thing I have written over there. Note, though following methods are used in the context of threads, the methods are given in java.lang.object superclass, because these methods must be called in synchronized methods that are called from the threads. That means thread class run method. So where these wait and notify methods are used in the non-thread class methods, not in the thread classes. So not in the run method or thread classes. So they should be available to each and every Java class, each and every class in Java. So that's why they are given it object class. Join, yield, I'll come to that moment, because we are having sleep, yield and join, 3 explanations. With that we'll end up this. What is the signature of sleep method? Sleep method signature is int long milliseconds, int nanoseconds. Forget about the second one. First one you consider sleep long milliseconds. So my question is, where the sleep method must be used, and what is the right place to use the sleep method? So we are having 3 contexts. One is in the method where the logic is implementing, and second one is thread class run method, and third one is in the client. Client responsibility is only strictly to create objects of threads, and if interested, you can set the name of the threads, you can prioritize the threads and call start method on the threads, so their run methods will be called. So client responsibility is only to create thread object and start the threads, but not to influence any logic on that thread execution. So there is no meaning in writing thread.sleep method in the main method and in the client program, because his job is only to call the threads. If at all, if want to wait, where the wait should happen, the wait should happen in only 2 places. One, the preferred place of writing the sleep method, if you are interested to write, is in your method logic. Public void generate. These are the method where actual logic lies. System.out.println generate method code, and you write some logic over there. I am just writing debug statement. And in the generate method, you use thread.sleep of 100. And this method is something related to connecting to the database or connecting to some network. We know that network progress or database connectivity is little bit a slower process. So we want to sleep or method execution for some time. And why we are writing sleep? Because whenever we write sleep method in a method, immediately that will be noticed by the thread scheduler. Thread scheduler, whenever finds sleep written in any method, if any method is left for some specific amount of time, thread scheduler is such a mechanism that if any thread goes to some wait state or block state, immediately thread scheduler will give that thread's priority or the life cycle, the cycles or the time to the other threads to complete the execution. That is how threads improves the performance, but not makes the execution faster. Don't say execution faster. Threads improves the performance of our application. How? If any thread gets delayed, the thread scheduler will distribute the time to other threads to complete the remaining threads execution. Right. So where we need to write the sleep method, if you are interested to write, you write it in your method where the logic is implemented. So you're connecting to some database or network or something. It will take some time. At least 1 second it will take. Then you write 1000, thread dot sleep of 1000. 1/10 of the second, thread dot sleep of 100. Or 5 seconds, thread dot sleep of 1000 into 5. 1000 into 5 means 5000 milliseconds means 5 seconds, like that. So it is a responsibility of as a developer, it is a responsibility of, it is your responsibility because you are implementing generated method. It is your responsibility inside the logic. If your method, and if you get a doubt that your method takes some time takes some delay to execute, as a developer, it is your responsibility while implementing the method. You please inform the thread scheduler that my method waits for some time. So if you want to run any other threads to complete their execution, you let it complete. So how do you communicate to the thread scheduler through a method saying that my method may wait for some time? That you have to do it through a thread.sleep. And wherever you are using thread.sleep method, the method reports an interrupted exception, which is a checked exception. Checked exception is already discussed. So if any method reports any checked exception, that method should be handled with a try catch block. Interrupted exception E. So this is the first place where you are recommended to use thread.sleep method. Wherever you are implementing the logic, there if you have any doubt, like your method executes for some time, delays for some time, its execution delays for some time, and you want to instruct thread scheduler, please my thread is going to wait some wait state, so you please continue your remaining threads execution. If you want to inform like that, you will inform through a sleep. And as a developer, while implementing the method, you always keep in mind that how am I communicating with the thread scheduler, not just writing thread.sleep. The second place where we can use is while implementing the thread. From the run method, we are calling the generate method for 100 times or 10 times. Each time when we are calling the method, you write thread.sleep for 100. And if at all, if you want to call thread.sleep, you can call it in the run method before or after calling the method. Or mostly this method is preferred to be called from the method where the logic we are implementing, like generate method. But don't write thread.sleep method in the main method, the client program. Why? Client method intends to wait before starting the thread or after starting the thread. That should happen in the thread or thread running method, but not on the client, right? So that is the matter. So that is the story. Hope sleep method is clear to all of you. That is one of the method of the thread class. Coming to the two more important methods in thread class, these two are yield and join. As I mentioned previously, while implementing threads as a developer, should always keep in mind how am I communicating with the thread scheduler. The moment you create thread object, you'll call thread.start method. So what does it mean? What does that t1.start or t2.start thread object.start, that method calling statement mean? The method calling statement mean that you are instructing or you are asking, you're requesting the thread scheduler to please register my thread along with other threads. For that, otherwise you could directly call t1.run. t1.start we are calling. So that makes the thread object first go and register to thread scheduler. And thread scheduler schedules the time, how much time each thread want to run. That will take care of calling the run methods. That is thread scheduler responsibility. Similarly, sleep now, as we discussed, sleep also. We requested thread scheduler saying that my thread want to wait for some time. So you please continue with the remaining threads execution. So how do you instruct or how do you request thread scheduler saying that my method will sleep for some time? Thread.sleep. Similarly, wait and notify methods. Whenever your method already executed once, you'll notify other threads to executing in synchronization. But your thread want to wait first. So the moment wait method is called in the generate method, that generate corresponding thread goes to wait state. So whichever threads remaining in the queue, those method executions will continue because notify is called. So there also through our wait and notify, we communicated to thread scheduler which thread we want to run and which thread we want to notify. Similarly, the two methods, yield and join also. So what is the purpose of yield method? The yield method, and on any thread object, if you call t1 dot something like yield, yield, yield. A yield method stops currently executing thread and will give a chance to other waiting threads of the same priority to execute. Now, on any thread object, if you call yield method, immediately it will stop its execution. Whichever other threads are running along with our thread or co-running threads, our thread will immediately stop. It will allow co-threads to continue their execution and its execution will go to end. When all our preceding and succeeding thread executions are completed, when system comes to idle, when there is no race in the thread scheduler, when no threads are there in the thread scheduler to run, if the thread fails, then finally that thread will execute. And it will send its priority to the end. It will execute at the end of the all threads execution. So that is what yield method. Yield stops currently executing thread and it will give chance to other waiting threads of the same priority. If in case there are no waiting threads or if all the waiting threads have low priority, then thread will continue its execution. Same thing I have written here. Because we must implement multiple threads to run, because we implement multiple threads to run methods simultaneously, if any method, see this, the previous paragraph explains how yield function works. Say on t1.yield if I call, and followed by our thread, the two other concurrently running threads are t2 and t3. The moment you call t1.yield, it will immediately go to end of the thread scheduler and it will let t1 and t2 to complete its execution. t1, t2, t1, t2, t2, t3, t2, t3, t2, t3. Thread scheduler will take care of t2, t3. If once these threads execution are completed, then t1 will execute. That is what the actual meaning of the yield method. When to decide in which method we want to call the yield method, because we can implement multiple threads to run methods simultaneously. If any method, not thread, if any method, it's corresponding. That is why in the generate and run method you write this dot current thread dot yield. Whereas in the thread class run method you can call this dot yield. In the client program thread object dot yield. So yield method must be called carefully. It's a non-static method. Static or non-static? Oh, static method. Okay. You can directly call in the generate method. You can directly call thread dot yield. So to run, because we implement multiple threads to run simultaneously, if any method, its corresponding thread wants to go away from the remaining method's execution, because the current thread or the current method execution may not be as important as other threads. If at all, if any method or thread feels like, mostly method feels like, okay, my execution is not as important as my other methods to execute. Sometimes when we are standing in a queue, suppose in a bank or somewhere, immediately we'll get a call or we'll get a message to which we want to respond immediately. We want to take a pause for some time, some 5-10 minutes. We want to attend a call and we want to come back. We want to give a reply to some message and we want to wait for that acknowledgement, and then we want to come and stand in the queue. Then what we'll immediately do is we'll ask our next person who is standing in the queue, we'll ask him, you please continue. I'll come after 5 minutes or 10 minutes. I'll resume after 5 minutes or 10 minutes. But soon after you resume back after 5 or 10 minutes, your chance may not be given. Your position may not be given. You'll go and stand in the back of the queue. And again, you'll start from back, you'll come to front. Because people don't allow you to come and join in the middle again. Because you left from the queue, you have to go to the end and you have to come back again in the sequence. So that is what we generally do in the banks or anywhere we go. When we are standing in the queue, generally this is what happens. So, like that, if any method or thread feels like my method execution is not as important as other threads, that is one place. And secondly, our thread want to go out of the race with other threads because our method execution delays a lot in between its execution. And I know my method execution takes a lot of time. Because of that, I do not want to disturb other threads for my method execution delay. So I'll call yield method. Let my thread goes to last. Once all my preceding thread executions are completed, then finally I'll execute. When there is no race in the thread scheduler, when I am the only thread, I'll execute it. So how do you instruct such an instruction to the thread scheduler? By calling yield method on your thread. On such method, if you call yield method, the method goes to end of the thread scheduler, and when no methods are running, then the yielded method executes. So you can call t1.yield method anywhere in the program. Mostly in the application, see, if you know the functionality while implementing the thread, you can use it in the method or you can use it in the thread. That you can decide. That example is complete. Yield is complete, but still if you call yield method, the thread won't die. The thread will go to the end of the queue, and once all preceding thread executions are completed, as a last thread it will execute. But it won't die. The thread won't die. Coming to the join. Join method called on one thread joins with other threads to instruct until the first thread execution is completed and dead. The other threads don't want to start their execution. For example, if you start, here is one join example, join thread example. In the run method, we iterated loop for 3 times, and each time when thread starts, the thread iterates a loop for 3 times. Each time when loop is iterating, it's sleeping for 1 second. 1000 milliseconds is equal to 1 second. Then it prints system.that join example I. The next of 1000 milliseconds, once again it is called, then 2. Once again 3. And every time first it delays for 1000 milliseconds and then it will print its value. Such an example, join example 1. We created 3 thread objects. This join example plus 3 objects we created. If you call t1.start, t2.start, t3.start, what happens? t1.start, first run method executes. For loop starts. In the first iteration, 1000 milliseconds is the delay. After that, first this join output should come. Then here we are creating same thread class object 3 times. You assume that these 3 threads are different thread classes. This is join example. And there are other classes called join example 2 and 3, in which in those run methods, there may not be any delay, something like this, thread.sleep. But there is a sleep process only in the join example. Join example 1 and join example 2 class run methods are not having any sleep before doing their processes. And they can run faster. If you run t1.start, t2.start, t3.start, t1.run starts a run method, first time loop iterates 1000 milliseconds. After this statement will come, because of 1000 milliseconds delayed, immediately second thread starts, third thread starts, their run method executes. Because there are no delay in those methods, those threads will complete their execution. That's all. If there is no delay time in the first thread, then along with the first thread, the second and third threads will also run simultaneously, concurrently. This method for this thread for some 10 iterations, then another for 15 iterations, then another one for some 20 iterations, like that. But coming to this here, my point is t1.start I called, and I'm asking thread 1 to start. Immediately if I call t2.start and t3.start, other threads will also start. And because of this thread delay, The other threads will complete their execution. That we don't want to do. So what we want to do, until our join example 1 thread object execution, all its 3 iterations and the complete run method executions are completed, I do not want to start second and third threads. Once my thread execution starts, until my execution, all executions are completed, I don't want to. And in the multi-threaded environment, we want to run my thread with other threads sequentially. Let other methods execute simultaneously. That we don't know. In multi-threaded environment, our thread want to run sequentially, and our thread and next thread want to run sequentially. The remaining threads want to run simultaneously. So, how do you instruct thread scheduler until my thread execution is completed? Please don't start other threads. So immediately soon after you start your thread, you call t1.join, calling the join method. After that you write, and because this when you are using join, sleep and these methods, you need to put it in try catch block, handle with some exception. Then you write t.start and t3.start. Until t1 all its executions are completed, join example 1, join example 2, join example 3, all its outputs are completed, all its executions are completed. Thread 2 and thread 3, actually these two are also objects of the same thread class, or these two objects can be objects of some other thread classes. Until the first thread, its all executions are completed. Second and third thread executions don't start even for a single time. So that is how until our thread execution is completed, we don't want to start. If you don't want to start other threads to start their execution, you call join on your object. So until your thread execution start, execute and dead, no other threads next in the sequence will execute. This is example on join. Now, as a last topic, I'll come to interrupt here. I'll come to thread lifecycle. Now you see the thread lifecycle. In the client program, whenever you create a new thread object, some generate thread GT is equal to new generate thread of or M1 thread is some M1 thread is equal to new M1 thread. Whenever you create a new object of thread, before calling start method, your thread object is in the start state. I mean, your thread object is in the new thread state. So where that new thread state that state comes in the main method, the client. Then on the thread object you'll call start. The moment you call start, what happens? Thread object will register into thread scheduler, and from the thread scheduler run method will be called. Then to which state the thread will go? To run state. So in the run state, the thread continuously runs with other threads concurrently. Then somewhere in the thread run method, thread class run method, or somewhere in the method which is called from the run method. Mostly we implement logic in the generate method and print method. So which methods do you mostly call? You'll often call in the generate method and print method. Sleep, in the previous example I've explained. Sleep. Suspend is deprecated. Wait. Join. Yield, where all these methods are called. 3 classes. Class which contains multiple methods, thread classes and client. Where most of these methods, sleep, suspend, wait, join, yield, these methods are called. Where mostly these methods are called. In the methods or in the thread classes. In the methods. Like in the generate and print kind of methods. Methods which we want to run simultaneously from various threads. In the method we'll implement logic, there we want to write these interrupt statements. Okay. Whenever you call these statements like sleep, wait or join or yield, these are all instructions to the thread scheduler so that thread scheduler will blocks your thread execution. Will stops your thread execution, right? So you call any one of the method, your thread goes to block state. From block state, when the state of the thread will return back. If you call thread.sleep after time lapse, automatically, if you give 1000 milliseconds 1 second, after that, thread automatically comes back to execution state. If you call suspend, you need to call ratio. If you call wait, you need to call notify or notify all. Okay. If only 2 threads, call notify. If multiple threads are there, notify all. And no doubt from the runnable state, if any of these methods are used in a method, thread will go to block state. Once it's a block is completed, it will resume back to our runnable state. And once the complete thread execution is completed, from the run method you're calling the method, and the method, once its complete execution is completed, then method will come to end. The corresponding thread will go to dead state automatically. So that you needn't have to do. You just call start, implement your method logic. You call any of these methods. Thread will temporarily go to block state. Again, it will come back to run state. Once it's completed, it will go to dead state. But from any one of this state, if you want to bring thread forcibly to dead state, then you can call. Stop is an interrupt method. Stop is a deprecated method. You call interrupt method. From any of this, from new thread state or from runnable state or from block state, you call stop or interrupt. Your thread will immediately stop. This is the overall explanation. That is why I kept thread life cycle at the end of the explanation. Before that, the thread methods explanation. Before that, we spared most of our time on various ways of implementing threads. Hope this session is helpful to all of you. Here ends, the threads concept ends. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.